Thanks everybody for listening today. I'm Daniel Harrison and I'm a senior lecturer at the National Marine Science Centre at Southern Cross University. And today I'm going to talk a little bit about some of the potential benefits and risks of using cloud brightening as a potential mitigation for coral bleaching on the Great Barrier Reef in Australia. I'm part of a program called the Reef Restoration and Adaptation Program. And this is, we think, the world's largest ever effort to help a significant ecosystem, in this case, the Great Barrier Reef, which is, the size of Italy, the world's largest living structure, to survive the coming impacts of climate change. And so already the reef is suffering a lot from climate change. You may have seen the news, over the last 5 years, we've had 3 mass bleaching events and we've lost more than half of the shallow water corals on the reef in just those few years. And so in our program, we have a collaboration of scientists, engineers, and other experts in things like cultural science and governance and regulation, all coming together to look at a really broad range of ideas that might be able to provide additional tools to the managers of the Great Barrier Reef, the Great Barrier Reef Marine Park Authority. We're looking for extra solutions that they might be able to have in their toolkit and use in their management of the reef to help it survive the coming decades, essentially. And the challenge is huge. The ideas that we're looking at in this program, we've set a pretty high bar. They have to be scalable enough to make a meaningful difference ecologically, at the scale of this reef, which is, the size of Italy. And so, why do we need to intervene? Why do we need to start looking into these ideas that are so far out there? Things like cloud brightening, things like trying to help corals genetically adapt to warmer temperatures, and even down to looking at things as extreme as genetic engineering of corals, or IVF for corals, where we capture larval slicks when the corals spawn and then try to force those larvae to settle back down onto the reef to reduce the amount that are lost into the open ocean and help restore reefs. And the reason for this is because climate change is now the most significant threat to reefs, not just the Great Barrier Reef, but all around the world. Based on sort of current emissions trajectories, if we keep going on the path of climate change business as usual, reefs all around the world are predicted to be catastrophically declining by 2050. The water is rapidly becoming too warm and changing too quickly for the corals to keep up. And so why don't we then just focus on reducing emissions? That's what's causing the problem. So why don't we just get our act together, start reducing emissions, and then hopefully the corals will be all right. Unfortunately, the simple answer is we've waited too long, basically. We needed to drastically start reducing emissions decades ago. And the reason for this is because there's already a certain amount of climate change built in, based on the amount of carbon dioxide that we've already emitted to the atmosphere. And on top of that, at the moment, we're showing no signs of slowing down. So I've made a plot here where I show in orange where the reef is bleached moderately back in the El Nino years of 98 and 2003, and then those 3 severe mass bleachings event we've had over just the last few years. And you can see that they're superimposed on the Earth's temperature there. So this is the change in temperature from the baseline due to climate change. And so we're up here now at about 1 degree of warming on average for the planet. And I've marked in there the Paris range where we hope that we can maybe stabilize temperature increase at around 1.5 to 2 degrees, but that would require drastic action on climate change, which we're still not seeing. And so it's, current predictions, I think, that are the most reasonable are that we're going to go even warmer than that. And I think this plot quite clearly shows that without help, the Great Barrier Reef's not really going to be able to survive those changes. And so one of the ideas we're looking into in the Reef Restoration and Adaptation program is apply cloud brightening, which has been considered up till now as a global type intervention to help cool the entire planet. We want to look at whether you could apply it just locally over a much, much smaller area to help stop corals bleaching. And so the major difference really is that if you were trying to cool the whole planet, you'd be doing cloud brightening in very major, large regions of the world's oceans, and you'd be probably doing it all the time. Over the reef, we're looking at just doing it directly over the reef, and only in those summer periods when the waters were exceptionally warm and the reef was at very high risk of coral bleaching. And so we've got a research program that we're embarking upon to look into these questions. And primarily we want to look into the efficacy, how well do we think this idea would work if it does work? How much protection could it help to give the reef? And to what degree of climate change would it still be able to help? We're going to look into the risks. We also have a large effort to look into the social acceptability, because ultimately all of these different ideas that we're looking into for the reef will never be applied if they're not also socially acceptable, even if they might be scientifically robust. And so the program consists of a very large stakeholder and traditional owner engagement and co-design process. So, right from the start of this journey, we want to take along traditional owners, the traditional custodians of the reef, as well as all the other stakeholders, the Australian public, tourism operators, recreational fishers. The Australian public has a very great affinity and strong cultural connection to the Great Barrier Reef. And so it's essential that we as scientists are acting hand in hand with all of these stakeholders rather than just doing our own thing. And so then, of course, there's quite a strong technology development component. At the moment, the technology to do cloud brightening or even to test it doesn't exist. And so we have to put quite a lot of effort into developing that technology to enable us to actually test these ideas and see if they work in the real world or not. And then, of course, associated with that, with both the technology development and the testing and eventual potential implementation, it's critical to consider all of the risks. While there could be quite a lot of benefits from doing cloud brightening for the reef, there could also be risks to both foreseeable risks and also potentially unintended, unexpected impacts. And so, as part of this research program, we're not moving to implementation. The idea is to just do enough to understand whether this, to quantitatively understand how well this would work. And so, the testing that we hope to do as part of this program is very small scale, short duration, to eventually look at how do the clouds respond in a very small, limited area for a very short period of time, perhaps a few days. And so, what are the potential benefits? Why are we looking into this? Out of all of the greater than 100 ideas that might be able to help the reef that we've considered in the Great Barrier Reef Restoration Program, cloud brightening or sort of large-scale solar radiation management is potentially one of the best options that we've found so far. And the reason for that is because it protects the entire reef. If it works how we hope, you're actually preserving the ecosystem that's there. You're preserving the young corals as well as the corals that took thousands of years to grow. You're not just protecting corals from heat stress, you're protecting the sea anemones, which also actually bleach, and you're protecting the seagrass and the fish that rely on all of those things for their habitat. And you're preserving the entire ecosystem as much as you can, or help to preserve it in its current state, as opposed to a lot of the other ideas and what's happening sort of globally in reef restoration now. You're largely trying to replace an ecosystem that you've lost. You're trying to do coral gardening and put corals back out there after they're gone. And of course, when you're doing that, you're by nature, you can only do that with a limited number of species and a limited number of corals, and corals that the process works for, the more hardy corals perhaps. And so you're fundamentally ending up with a different ecosystem than you have now. The other great advantage of an idea like cloud brightening for the reef is that it's inherently scalable. In fact, with the idea of cloud brightening, we've sort of taken this idea that's been envisaged for the whole globe, and we're actually scaling it way, way, way down to just apply it for a limited amount of time over the reef. The reef is less than 0.07% of the world's surface, so it's a very small area for cloud brightening, but a very large area for planting corals. And so during the preliminary phase of our program, we've done a lot of modeling to look at the potential benefits from the different ideas. And what you can see here on the right is in blue, looking at how cloud brightening could help if we have really strong action on climate change and we're able to reduce our emissions to approximately meet the Paris climate targets. And what we can see in that case is that without cloud brightening or large-scale solar radiation management, the reef declines from its current coral cover of about 20%. So that's, 20% of the reef is covered by actual living coral at the moment. It declines down to about 10% or so and then holds fairly steady if we meet Paris targets in this modeling scenario. But if we have cloud brightening and we meet the Paris targets, then we're able to more or less maintain the reef at the current levels of coral cover. And if we combine cloud brightening with some of the other ideas that we're looking at in the reef restoration and adaptation program, and they all work really well, then actually we can increase coral cover back towards more historical levels. However, in the bottom plot there with the red shading, you can see that if we're unable to meet Paris climate change targets and we keep going on a sort of more business as usual type scenario of not really very strong action to reduce our emissions, which is the current trajectory that we're still on the moment, unfortunately, then what you can see is the reef declines over the next 50 years or so until it's more or less gone. And very, very low coral cover. There'll still be some reef structure there, but it'll be catastrophically changed from what it is now, and irreversibly so. If cloud brightening works as well as we hope it might in that type of a scenario, then it's really not enough. It helps preserve the reef for a couple of decades there, perhaps out to 2050 in this scenario, but eventually it's overwhelmed by climate change because you can only get so much cloud brightening, and that can only help cool down the water a certain amount. And of course, if we don't do anything about reducing emissions, then that just eventually is not enough to help. And so there's a really, really strong message there, I think, which is quite unavoidable, and you can't get around it, that the cloud brightening in terms of trying to help the reef is no replacement at all for reducing emissions. The best chance that the reef has is if we do both and they both work. So what are some of the risks that we need to worry about? Of course, the larger the scale of the action that you take, then the greater the risk. For example, doing cloud brightening over the whole reef involves more risk than perhaps making a really large shade cloth over a single area of reef that's important for tourism or something, for example. The risks are higher with the larger the area, and if you were to do cloud brightening for the whole world, then the risks go up again, of course. The risks are sort of basically proportionate to the scale of the implementation to a large degree. And so we can look at some of the risks that people are worried about with cloud brightening for the planet and also for the Great Barrier Reef. And so the area of the Great Barrier Reef Marine Park, as I mentioned earlier, is about 0.07% of the Earth's surface. So the footprint of risks and the type of risks that you worry about are quite different. Some apply, some don't apply, and some apply in different ways to how you might look at global cloud brightening. And so one of the things that, of course, is one of the most obvious risks and first comes to mind is that by doing cloud brightening, you may change the hydrological cycles. You might change the amount and the place and the type of rainfall, for example. And, we know that this risk is quite high if you were to do cloud brightening globally, because scientists have been looking into this for some time and doing some modeling of it. We don't really know yet for the Great Barrier Reef, and so that's part of our research program, is to look into that, and we'll be making regional atmospheric models that use the same model that they use for weather forecasting, and then look at how these small changes to the clouds, whether that could also change rainfall. But I showed on the previous slide that rainfall along the northeast Australian coast is some of the highest in Australia. So it's very tropical up there with an awful lot of rainfall. And at a very first guess, we might expect that doing cloud brightening during the summer for a couple of months, which is when you'd maybe need to do it, might slightly reduce rainfall in northeast Australia, but we're not sure yet. The other thing to note there is that there's also orographic lift processes that mean that a lot of that rainfall is caused by clouds, the wind and the clouds sort of hitting the mountains when they come onto the land there, and that causing the rain. And so it's also possible that cloud brightening won't make much difference at all to the rainfall. Another risk that people worry a lot about is transboundary impacts. So if you do cloud brightening over quite a large area, it's uncontained, it's in the atmosphere, clouds move around, as do weather patterns, have teleconnections between different places on the planet. And so on a really large scale, you might do cloud brightening in one place and you might adversely affect another country across international borders, for example. And so the risk of that is really quite high in global use of cloud brightening, but we think it's quite low doing cloud brightening over the Great Barrier Reef, although, again, it's something that we still have to look into in the program. Another thing people worry is about the termination effect. Cloud brightening would not be addressing the underlying problems of climate change. It's more a sort of a treatment for the symptom. You're trying to cool, in this case, the waters back down to help prevent the corals bleaching, but the underlying buildup of carbon dioxide is still there in the system. And so people worry that, if you did this for the whole planet and you were cooling the whole planet down with cloud brightening, what happens if in 10 or 20 years' time, you suddenly stop, governments decide it's too expensive, or there's a war, or any other reason, and you suddenly stop, you get all of that temperature increase at once. So we have to worry about this effect if we're doing this for the corals too. For example, what happens if cloud brightening is working really, really well? We're preventing bleaching on the reef, and 10 years down the track, the government changes and says, hey, we're spending all of this money doing cloud brightening. The reef hasn't bleached in 10 years. We don't believe it's cloud brightening that's stopping it, so we're going to stop doing the cloud brightening. Then we have to worry about whether that will cause more stress to the corals with less chance for natural adaptation than they would have had otherwise. And so that's something that is a risk that we need to look into in terms of natural adaptation, and how much cloud brightening is enough to stop us losing the reef, but also allow the coral to have some stress so that they're also naturally adapting to the changing system. Then, irreversibility. People worry about these ideas that you might create some sort of change that you can't take back. The good thing about cloud brightening, especially as it's applied to the reef, is that the changes are very transient. The clouds and the salt crystals that you're launching into the atmosphere only last a day or two, and the clouds have a very short lifetime over the reef as well. And so if you were seeing side effects that you didn't like, you could just stop doing it, and the system would go back to normal quite quickly. So the risk of that's quite low, I think. Another thing people naturally worry about is, you're going to be pumping all of this extra salt into the air. What impact would that have on farming, for example, if it blows over the land? It's very hard to get your head around this, but the salt crystals are so minute that, the testing we've done so far is that one nozzle is producing 3 trillion of these nano-sized salt crystals from just a 0.2 milliliters of water. So it's incredibly small. And in fact, most of the clouds coming in over the reef and then over the land in northeast Queensland are already seeded by sea salt. So all of that rain that falls on the land, each drop already has a tiny little salt crystal as its nucleus. And so this is no different. We'd just be making slightly more. And the final risk that we can also worry about is people might imagine that we're going to create all of these clouds over the reef and sort of darken the sky, and then there might not be enough light for other ecological processes that go on the reef, the phytoplankton in the water, for example, or the coral symbionts themselves that harvest light energy. But the scenarios that we're looking at is that we showed in that modeling before, is that it's only a change of 3 to 6% in the light, and that's enough to completely alter the trajectory of the reef. The real question is whether it's technically feasible to get that change or not. That we don't know yet. But we're able to sort of put that change that we think we might be able to achieve into the models and then look at how much of a difference that makes to the coral, and it's a lot. So, that's sort of within the natural variability of the light from year to year with different weather patterns and different levels of cloud cover. So it's not a change that's going to cause adverse impacts. Another thing that's very, very important in this research is the aspect of governance. And so for our program to be successful across all of these different interventions that we're looking at, it's absolutely incredibly important that the public has confidence and the stakeholders have confidence that the program is being well managed and that we're not taking unreasonable risks in our research. This is actually an ideal place for this sort of groundbreaking research to occur in the Great Barrier Reef, because it's already one of the best managed and most regulated ecosystems in the world. So anything at all that we do on the reef is subject to assessment by the Great Barrier Reef Marine Park Authority. And in addition to that, we also have an internal risk oversight panel that brings in external experts to assess the risk of everything we're doing. And then on top of that, if we're ever to do experiments that are deemed by the Great Barrier Reef Marine Park Authority to be large enough to potentially cause adverse consequences, then there's another level of the Australian federal government Environment Department has a regulatory assessment process as well, which we would need to go through. Equally important as that regulatory framework is the engagement with stakeholders and traditional owners. And so we have a whole team and a whole funded program, sub-program within our program that's dedicated to doing research and engaging with traditional owners, stakeholders, and the general public in order to understand and incorporate their views and their opinions and into co-design of the whole program. And so what does that actually look like? It means that we're actually engaging with these stakeholders and with traditional owners, and we're not doing anything essentially in the program without free, prior and informed consent. So anything that we want to do on the reef at all in terms of testing a new intervention or research, we're consulting with stakeholder groups and we're consulting with traditional owners, and we're seeking consent from the traditional owners, the local custodians of that land and that area of reef before we're doing experiments, for example, or fieldwork. Some of the research that we did during the first phase of this program was to conduct surveys of both the public and stakeholders that live close to the reef. And what we found was that there was quite high in-principle support for taking action on the reef. The vast majority of Australians agree that the reef is an important national asset, agree that we need to do more to save the reef, that they support looking into new and novel ideas, and that they support large-scale intervention to help protect the reef. And if we look at some of those survey results for cloud brightening in particular, the level of support was quite high. So on this plot, the respondents were asked, how acceptable do you think cloud brightening as an idea is to help prevent coral bleaching and help preserve the Great Barrier Reef? They were asked to rate it on a scale from 1 to 7, with 1 being not at all acceptable and 7 very acceptable. And as you can see, the data was quite right skewed. Most of both the population and the stakeholders living in close proximity to the reef gave an acceptability between the mid-range and very much acceptable. And so, we think, but one of the other things we learned during the survey process was that people don't really understand the idea yet either. So we still have a lot more work to do to help explain to people exactly what it is that we're thinking of doing and what are the pros and cons. But I think this results really showed us that, the Australian public, the reef is very, very important to them, and that they understand that, if we're going to save it, we're going to have to try really bold, really big, really new ideas, because the research shows us, and people can see this from themselves over these last few bleaching events, that the prospect for the reef without intervention is not very good at all. And so thank you for your time.